Hello, welcome to this on GCSE physics um, class or tutorial on mechanics. Okay, mechanics is one of the most interesting topics I feel in physics. Especially if you're doing the Cambridge IGCSE program or just the UK GCSE program. Anyway, so we've often been told that speed is equal to distance over time, correct? So we've often been told that speed is equal to distance by time. Now, actually, this is not just the speed, the general speed. This is the average speed, okay? Um, now, let's say we travel a distance of 20 meters in let's say 5 seconds. Okay, you're gonna get a speed of 4 meter per second. Okay, now let's say this was the speed taken for a car to travel from A to B. Okay, now let's say the car took as per our calculation, the average speed is 4 meter per second. But if I'm saying average speed over here, what is the actual speed? Well, so we've calculated the average speed taking into account the distance from A to B is 20 meters, and the car took 5 seconds to travel that 20-meter distance from A to B. So we generally say that the car has a average speed of 4 meters per second. Well, the actual speed can vary. So for example, the car can go faster from here to here, and then might go slow over there, but we'll still be able to travel that 20-meter distance in 5 seconds. So we don't really know, because the car speed may vary between this and this. I just gave an example, but we just say that average as an average, the speed is 4 meter per second. While it might actually go fast in one case, slower in one case, but still cover a 20-meter distance in 5 seconds. So we don't know the actual speed, and it's not quite easy to use actual speed in many calculations, because you will have to take the shortest possible time and then add them up. So in physics we generally take the average speed, which is distance by time. Now speed is a magnitude, okay? Magnitude basically means like a quantity. For example, 4 meter per second, if you just take 4 is a quantity. Yeah, it's a quantitatable value, and that we write it as 4. But velocity is basically speed plus a direction. Okay? Now, what is speed? Speed is a magnitude, like I told you. Okay? So velocity is magnitude and direction. So velocity is a vector. So basically what a scalar, so speed is a scalar quantity. Okay? Scalar basically means that it just consists of a magnitude. For example, 4 meter per second is just the speed. So it's just the quantity. So we call that a scalar quantity. However, velocity it also includes the direction in which an object is going at that certain speed. So velocity is a vector quantity. So that's the difference between a scalar quantity and a vector quantity. A scalar quantity is basically a quantity that consists of so let me write that down. Scalar quantity is a quantity that consists of a magnitude only. Example is speed of 4 meter per second. Vector quantity, on the other hand, consists of a magnitude plus a direction. For example, the speed of 4 meter per second to the right. Okay? This can also be written as plus 4 meter per second. Right means positive. If you're writing a left, it means negative. So if you write negative 4 meter per second, it means that you're going the direction of the left. This means you're going to the direction of the right. Okay. So now that we've covered the introduction about the difference between speed and average speed, and why we take average speed, because it's a lot easier than taking into account the actual speed. Also talked about what is the difference between a scalar and vector quantity, and the fact that you could also represent a velocity, which is a speed plus direction, with a plus or minus sign. The plus will represent that the speed, the car or any object is going with this speed to the right, whereas a velocity of minus 4 meter per second basically means that the car or any object is going with 4 meter per second to the left. Okay, so that is that. Another thing that you would like to know is acceleration. So acceleration, let me write that down. So basically, the formula for acceleration is v minus u divided by t. Now, v indicates final velocity, u indicates, that's a u, initial velocity, and t indicates time. Now say for example you have let's say your initial velocity. So let's say hypothetically a car is has an initial velocity of 0 and a final velocity of 12 meter per second. Okay, and it's taking 4 seconds to do that. So it's taking 4 seconds to come from 0, which is its initial velocity, to 12, which is its final velocity. It's taking 4 seconds to do that. Then your acceleration would be v minus u by t, which would be 12 minus 0 divided by 4, which is going to be 3. Okay. Now, speed or velocity is written in meter per second, but since you're dividing a meter per second by second, your acceleration unit is meter per second square. Okay? What the value of acceleration basically tells you is that a car, for in this example, a car, the car speed. So if you see a speedometer in the car, it's going to increase by 3 meter per second every second. So every second you're going to see that your speed in meter per second is increasing by 3. It's like, so something like that. So your speed is technically increasing by 3 meter per second every second. And this is what acceleration means. Okay, and it's therefore written as meter per second square, because every second your speed is increasing by 3 meter per second in this case. Now, positive acceleration just means that your speed again is increasing by 3 meter per second every second. But a negative acceleration is something that's known as deceleration. Okay, deceleration basically means that your speed is decreasing. So if it's negative 3 meter per second the square, it just means that your speed is decreasing by 3 meter per second every second. So that is known as deceleration. Now, if we look back at the formula for acceleration, which is v minus u divided by t, v minus u will just give you velocity again, right? So you can just write it as v by t, right? Velocity. So if you're given acceleration in the question and time in a question, you ask to find velocity. Don't get confused. Velocity is just acceleration into time. You can derive it like that, because finally, final velocity minus initial is going to give you velocity itself, right? So therefore, if you're asked to find velocity, it's just acceleration into time. Okay, so we've covered all of that, and now we're going to go and cover the distance time and speed time graphs. So basically these are the basics of distance time and speed time graphs. So let's get started with the distance time graph. Okay, distance time graphs. Now in a distance time graph, so what was distance by time? So distance by time gave you average speed, correct? So if I were to have a graph like this, okay, if I were to have a graph like this, then and if I had a gradient like that, my gradient would be equal to my speed in the distance time graph, because distance by time gives me speed. Okay, now another example, if I have a distance time graph, and this is my origin like always. In another example, if I have a line, straight line like that. Now what does this mean? This means that as my time is increasing, my distance on the y-axis is staying the same, which means from my vehicle or anything is parked, you could say 50 let's say this was 50. You could say that my vehicle was parked or at halt 50 meters from origin, because as time is increasing, the distance is not increasing, so you can say that the object is parked. And if you have a distance time graph with a curve like that, it just means acceleration. This is for a distance time graph, okay? Now let's come to speed time graph. Speed time graphs. In a speed time graph, what you need to keep in mind is the fact that like again, so if I write acceleration as v minus u by t, which is just velocity, your velocity would be acceleration into time. Again, that's a recap, okay? But acceleration is velocity by time, correct? And speed of velocity is the same, like or approximately the same thing, if you're getting me. Speed is just the magnitude, velocity is with the direction, so it's a vector. But essentially they both have the same magnitude. So speed, or velocity by time, is going to give you acceleration, correct? So my gradient in a speed time graph, as speed by time is acceleration, is going to give me acceleration. Okay, get it? So in a distance time graph, distance by time gives you speed. The gradient is equal to the speed. In a speed time graph, speed by time is acceleration, so my gradient is acceleration. Okay? Now, in a speed time graph, if you were to have in a speed time graph, if you were to have a straight line, it just means that let's say this is 20, right? It just means that the object is going to have a constant speed of 20. This means constant speed, okay? Because it's just constant. The speed is just constant, correct? As time is increasing, the speed is not changing. It's just remaining the same. So the object has a constant speed. And you must know that in a speed time graph, the area under the graph is equal to your distance. Okay? Now, in exam questions for your IGCSE physics paper, especially in paper 4, will always ask you to find the distance. And in this case, it is half times base into height, because this is the area of a triangle. And the distance is equal to the area under the graph. So that's that. And another thing is this: if you have a curve in a speed time graph, okay, so if you have a curve in a speed time graph, okay, for example like that, if you have a curve, it just means non-uniform acceleration. Non-uniform acceleration. Okay, so that's that. It just means non-uniform acceleration. And yeah, so now if we were to take an object that is going to let's say you have a container, okay, and you remove all the air from it, So there are no air particles, there are no gas particles in it. It's just completely empty. Okay, we call this in physics. We call such a environment a vacuum. Anyway, right? We call that a vacuum. And so let's say you had a heavy metal ball. Okay, you had a heavy metal ball, and you had a feather with the same distance and the same height, you could say, and you were both to drop them. You would drop them both. Which do you think would hit the ground first in a vacuum, where there are no air particles? Well, if you think the metal ball is going to hit the ground, the base of the container first, that is not right. See, the thing is that if there's no vacuum, there is no air to slow the. So basically, you should know that every object every object has the same acceleration. Okay. Towards the ground, and that's known as acceleration due to gravity, which is 9.8, but you generally take it as 10 in your IG exams. 10 meter per second. Meter per second square. Okay, you generally take it as 10 meter per second square. So that is the acceleration due to gravity. Okay. So basically, these both, the metal ball and the feather, will have a acceleration of 10 meter per second square. Okay, so which means they both technically will hit the ground at the same time, because they both have the same acceleration, right, in a vacuum. But if there were air particles present, then the air particles would provide air resistance and slow the feather down, because of course the feather has, more surface area and stuff like that. So the ball would reach the ground first, okay, if there was no vacuum and if there was air, which is why in theory, when we're just throwing a ball and a feather down in say a physics lab where there is air present, the metal ball will hit the ground first and not the feather, because the feather is slowed down much more by air resistance, or by air, you could say. So that is acceleration due to gravity. Okay, acceleration due to gravity. Okay, this is acceleration due to gravity. Now we'll come to an interesting concept, which is skydivers physics, and I'm gonna really show you how skydivers work and how they basically why like how is it safe to jump out of an aircraft. So and why is it so common these days. So first we need to understand what is a force. So what is a force? The force is basically a push or a pull. So if I had an object here, let's bring in some objects. So if I had an object like that, I could either push it or I could pull it. I could push it or I could pull it. This pushing and pulling movement is called a force. Okay? This pushing and pulling movement is called a force. So basically, force is measured in newtons. Okay? Force is measured in newtons. Okay? And 1 newton is basically the force required to move 1 kilogram, give 1 kilogram of mass an acceleration of 1 meter per second. So that is what 1 newton is. So yeah, now if I were to have an object, so this is commonly what they ask you in MCQs paper 2 of IGCSE. So if they have a car which is going with which has a driving force, a force provided by the engine of say 50 newtons, and it has a frictional force of say 15 newtons, the resultant force of the car would be 50 minus 15, the bigger minus the smaller, which would be 35, but to this way, because this force is greater over here, so it's going to move this way. And this is something that's known as the resultant force. Okay, resultant force. Okay. Now, in skydiver, when a skydiver is jumping initially out of the aircraft, okay, so let's say you have the aircraft. Okay, let's say you have the aircraft. Okay, when a skydiver is jumping out of the aircraft, it doesn't have a speed, so its initial speed is its initial acceleration is um, basically its initial acceleration is acceleration due to gravity, which is 10 meter per second. Correct. Um, that's what it is. Correct. Now, uh, okay. Now, as okay, so I'm just gonna put something there. Yeah, 10 meter per second. Now, as you proceed, and as the skydiver is going to fall down and down, there's going to its velocity is going to increase, and its air resistance, which is the force acting upwards against the force and against the direction you want to go, is increasing. But your weight is still greater. So because your weight is still greater, you're still gonna fall down. Now, eventually, what happens is your air resistance and your weight is equal to mass times gravity. Okay, your weight and air resistance are going to balance out. Okay, so because your air resistance and weight are going to balance out, you're going to have a constant velocity, which is also known as terminal velocity. Now, this terminal velocity is too high. It's too high to go on the ground, right? And because if you go on the ground with this terminal velocity, you're going to hit it too fast and you're going to die. So that's why we have parachutes. So when you open a parachute, okay, your air resistance will increase drastically because your surface area is increased. Okay. Now, because your air resistance is increasing drastically, your velocity falls. Okay? Because your velocity actually falls, what happens is your air resistance will also decrease. So eventually, again, your air resistance is going to balance your weight, and you're going to have another terminal velocity. Okay? Another terminal velocity. So now this terminal velocity is much lower than this was much higher, so you can safely hit the ground and be safe at the same time. So this is how skydivers physics is, and this is how skydivers physics works. So basically what happens, again, let me recap, is that as soon as a skydiver is going to jump out of the plane, the only force will be acting as its weight, i.e., it's not going to have any force or velocity, so its only force is going to be acting is its weight, which is mass times gravity, which is 10 gravitational field strength, which is 10 meter per second square. Your acceleration due to gravity is 10 meter per second, the whole square. Okay, so but then as you're going to the skydiver is going to fall, and the air resistance is going to increase and act upwards. However, the weight is still greater, so it continues to accelerate. Your bodies continue to accelerate towards the ground. But as the velocity is increasing, your air resistance is also increasing. Eventually, your air resistance and weight is going to balance each other out. And you're going to reach a terminal velocity, which is much higher, and you cannot safely land on the ground with this kind of terminal velocity, which is kind of like a balanced constant velocity. But if you open a parachute, your surface area is going to increase, your air resistance is going to increase, and eventually, because your air resistance is going to increase, your air resistance is going to be greater than your weight, and hence, because your air resistance is going to be greater than your weight, it has a net force of upwards, and that's why you see parachutists, when they're opening the parachute, the force kind of go upwards. When they open the parachute, they kind of go upwards, and then eventually, because air resistance is more, your velocity will decrease. So eventually, again, they will, and then because velocity is decreasing, air resistance also decreases, and eventually it will come in a balanced force again. Okay, it will come as a balanced force again, which is a terminal velocity, but with a much lower one, which you can hit the ground more safely. And yeah, so you can hit the ground more safely with that kind of terminal velocity. So we've covered all of that. Another thing I want you to cover is basically Newton's first law of motion, which basically states that if I have an object over here, and an object is at rest, if no external force is applied, an object is at rest, it will continue to remain. It will continue to remain at rest. Um, yeah. But if an object is moving, say in space where there is no external force being applied, it will continue to move in a straight line at a constant speed. And which is why if you just put a human in space, it's just going, or if you put if you put a human in space, he's just going to move if he does so with a constant speed in a straight line. If no external force is applied. So that is what Newton's first law is. Newton's second law, which we'll come to in another video, is equal to force is equal to mass times acceleration. This is Newton's second law, but we'll come to that in another video. So if you found this video helpful, hopefully you would please subscribe and like the video, and hopefully I will be publishing more videos to help you with your IGCSE exams, and with resources that I had collected over the 2 years of my program, which I wish I had in the very beginning to succeed from the very beginning itself. So thank you so much for watching. Please like, subscribe. Bye.